Hello everyone, my name is Cole and this is Lynn and Felix and we're working on the StandbyHome application. For 6+ hours every day, our homes are normally empty. And during this time, we usually leave on the heating and lighting systems. So our goal was to try and build an app that will put our home on standby while we're away, just like our phones and our computers. So specifically, we had two things that we wanted to do. The first was to automatically turn down the heating and lighting as much as possible in the home. And the second was to do this without making the user so frustrated that they would just stop using the app by making it convenient and making sure that the user remains in control of the app. So there's a fine balance here because on the one hand you need to reduce the temperature to a level where you can actually save energy, but on the other you have to at any time when the user starts to return home bring the temperature back up to room temperature. So to tread this fine line, we created a temperature setting algorithm that takes an input such as GPS, transfers that into information like the distance home or how close you are to work, and then eventually calculates from this information a set temperature. So this is the full algorithm, and all I want you to take away from this is that you have the inputs in orange translating into the intermediate steps in gray in the middle, and then on the right you have the yellow set temperature as the final result. So just to give you an example, here you have the current location right now and my past locations and my work location, as well as the time can be used to show that I'm currently at work. And this will all translate to a high probability that I'm also not about to return home, which is also helped by the fact that usually during these times I'm not going to return home immediately. This translates into two variables that we call buffer time and minimum temperature, which essentially just allows us to set a riskily low temperature currently of 14 degrees because I'm unlikely to return home anytime soon. So as well as the algorithm to also make the user happy, we've also implemented very easy to use controls so they can very quickly turn on and off the heating and lighting. And we've also implemented ways for them to get insight into how the app's functioning so they don't feel like they're losing control of the whole process.
Okay, first of all, we have the temperature control panel and the light control panel. They will be used for the user to manually turn on the lights and manually adjust the room temperature. Also, we have the temperature setting algorithm. This is the automatic algorithm. It will use to calculate the proper room setting temperature. And the input to the temperature setting algorithm is a location detector. It can be GPS, but in our demo we'll use Google Map. Also, after the temperature setting algorithm gets the result, it will send to the Arduino board through the interface. And then the Arduino board will send command to the light or the thermostat. Also, the temperature setting algorithm will store the temperature data and GPS location data to a database, and then the data will be plotted in the statistics diagram. Okay, here is a structure from the hardware point of view. There are two things I want to mention specifically. The first one is phone and the Arduino board. They don't need to be connected to the same network. The second thing is the reason why we use Arduino board is that we want to simulate the room control system. Also, here on this phone, this is a thermostat. That's it.
So if we just switch to the demo. So this is the main first screen in the app, which allows the user to control the temperature. So if you can see here, on the top right, you can see the thermostat temperature, and this allows the user to set the temperature while they're at home. But of course, we're currently not at home, so it's set it to a much lower temperature of 15.7 degrees. But if we were to start returning home, it would bring it back up. And I can override the automation right now by clicking return home, and it'll start to increase the temperature slowly. I can also get a bit more information on what it's currently doing by clicking the info panel, so I get a bit more insight into how the app works. Moving on to the light panel, this allows the user to control the lights both when they're just returned home and the lights don't turn on for some reason, or when they're, so you can turn all the lights on that way, or you can turn them on and off individually, in case you're around the home and you move into the kitchen and you just want to do it from your app. So for the chart view, to give the user insight again into how the app works, you have temperature over time, so they can see how it's decreased in the past. You also here have energy savings over time, just to encourage the user to save as much energy as possible. Going on to the maps view, so I can go to my work location, which is also my current location in this case, and I can go back home. I can also see the past route that my most recent points. So for this morning, I can see that when I left home, I can see a red icon, so I know that the temperature was very high. And as I start to move away from home, it notices that the direction is away, and then it starts to turn it down. But you can see as soon as I change the direction, it notices the direction change, and it puts the temperature back up just in case I'm turning around to go back. But instead, I just went to this spot and then waited for a period of time. And it noticed that I was waiting and staying in the same location, and so again, it started to turn it down back to yellow. I then took the subway all the way here, and then walked down. And you can see that as soon as I start getting near work, it starts to turn it to green, so it lowers the temperature even further. So again, this is just to give the user some more insight into how the app's working. And I can also, if I want, if the location is incorrect, I can change the location by just clicking somewhere on the map. And you can see because I moved away from work, it's turned to yellow. And I can also go all the way. If it's completely lost my GPS, I can just click near the home, and it'll show that I'm near the home again. And then the last page we have here is your settings. This just gives you some basic control over turning on and off the algorithm.
So the lessons learned from the entire project, like we noticed that pretty early in the later stage that we can implement the map view really earlier, so that it's really helpful when we are trying to debugging something, because we don't need to actually be into that location specific. And since we have 3 team members on the team, so previously we only do like one integration every week, but it turned out to be that's not very frequent, so we need to do more integration on that. And also we also learned that we need to use the sample code from the Google Map, like rate map other people, so that we can keep going, and the shortcut for the hardware. So right now, like this hardware, the entire hardware is accessible through the public network. So if we can make that happen really earlier, it will be helpful for other team members to make it as well. And for the future works, then so right now the current already support multiple users, but we haven't fully tested it. So our next step is to test it, and we're gonna fully integrate the control system in the house instead of using the Arduino board as a simulation. And also we'll keep optimizing the interface, so it will be more friendly. And also for security enhancement, we need to add in some authentication methods so that it will be better protected. Yeah. Thanks.
So thank you. Any questions?
Do you have a sense of, if you knew exactly where I was going to be, like perfectly through an oracle, how much money could I save by turning my heater on and off? Do you have any sense of what those numbers are?
So money I'm not quite sure of. From what we've seen, it's probably from around 20 to 30% of your energy. Because it does take up a very large chunk of your time. We say 6+ hours, that's if you're just going to school, but if you're going to work, it's going to be 8 to 9 hours a day. It's a very large amount of the time that you can just turn off your heating. And obviously you don't save all of that energy because you turn off the system for the whole period, but then it has to actually be brought on to bring it back again. But you can save a substantial amount of the energy for sure, if you have perfect information, especially.
That map that you showed, that was you this morning?
So To be honest, the map was the data points I edited just to make sure that they followed the right route, and so I didn't go way out of my way. But the what actually set the temperature at those points was the algorithm. So it was a simulated
specified.
Yes.
Position. Cool. Any other questions? It's good. It's nicely put together.